In this video note, we're going to work with the Music Organizer project. This project recognises that we don't always need to build everything from scratch. The idea behind the project is that we want to store a list of the audio tracks that we have on our computer. In this version, we'll simply store the list of audio file names, but in later versions we'll be able to store more detailed information, such as the artist, the track title, and even to play some sample files. The need to store lists of objects is very common in programs, and Java comes with some classes that already support lists. The class we're going to use is called ArrayList. It's part of an extensive library of useful classes that are known as the Java API. The Java class library is divided up into different packages, and the ArrayList can be found in the package called java.util. At the start of the class, we see an import statement for the class named java.util.ArrayList. This is how we introduce the ArrayList class name into our program, and then we can use it as if it were a class we had written ourselves. We can see the class name being used in the field of the Music Organizer class. Using the ArrayList class requires using a special notation that we haven't seen before. The field definition says that files is a variable whose type is ArrayList of string. This tells us not only that files will be used to refer to an ArrayList object, but also that the objects to be stored in the ArrayList will be strings. The string objects we should be storing will be the names of the music files. Before we look at the rest of the source code, let's look at how a Music Organizer object can be used. We create a Music Organizer object in the usual way. It has four methods: add file, get number of files, list file, and remove file. If we call get number of files, fairly obviously we get the value 0 returned. So let's add a file. Let's pretend that I have a file called song1.mp3, and now when I call get number of files, I see the value is 1. Let's call list file and pass in the value 0. We use 0 because 0 commonly means the first when we're dealing with programs that involve lists. Now let's add a second file. And of course we expect the second one to be listed as number 1. So now we have two items in the list, and calling get number of files should reveal that. Let's now try the remove file method. Let's remove the first one that we put into the list. Now what happens when we call list file 0? We see that now the first file is actually the second one that we added. Let's now take a look at the source of the Music Organizer class and see what we can learn from it. The first point to note is that we've used the same notation in the constructor for creating the ArrayList object as we saw when the files variable was defined. Notice that if you're using a compiler that's compatible with Java 7, then you don't actually need to include the type within the angle brackets. This notation is known as diamond notation. Here we see the add file and get number of files methods. Notice that they're actually very simple. They don't really have any functionality of their own. They simply hand over to the files object to do their work. The call to get number of files, however, does include a return statement. The call to files.size returns the number of items in the list, and this value is then returned by the get number of files method. We see a little bit more code in the list file and remove file methods, but actually most of that is to do with making sure that the value passed in as a parameter is valid before we pass it on to either the files.get method or the files.remove method. What we've demonstrated is that library classes can be used by importing them. Here we import java.util.ArrayList. We can then use the ArrayList type as if it were a class that we defined for ourselves. ArrayList uses a special notation to make it clear what type of objects will be stored in the list that's created. We repeat the same notation when creating the ArrayList object, but there's a difference with Java 7 in that we can leave out the type between the angle brackets. Using a library class means that we can often obtain sophisticated functionality without having to write very much code for ourselves, because the library class does a lot of the work for us. Here we've got the basis of a class that's going to be able to store an arbitrary number of file names, and we don't have to do any management of the list at all.